All right, welcome back to Mr. P. with Calculus. This is Unit 3, Day 4. We're going to be doing implicit differentiation today. All right, so warm-up was what on the last video. I would check that out. Implicit differentiation just means that you are differentiating something with respect to x that's not the letter x. In usual cases, you're differentiating something, you're finding the derivative when there's more than one variable. So it could be an x and y, it could be an a and a b, it could be any two letters or more. But if you're differentiating with more than one variable, then you're going to have to use implicit differentiation. And I'll explain why. Looking at the first question, if we're going to find the derivative with respect to x of x cubed, we've been doing that one for a while now, since Unit 1. That would simply just be simple power rule, 3x squared. Now, we don't typically write units for this, and here's the reason why. 3x squared is the derivative of x with respect to x. That's dx dx. We don't typically write this because there's no need to write this, because dx divided by dx is just itself, 1. And anything times 1, doesn't really change the value of anything. So there's a reason why we've never been writing any units here, is because it just wasn't important. But now you're going to see it is important. What if we're being asked to find the derivative? Find the derivative with respect to x of x plus y. Using sum and difference rule, I'm going to do these individually. Well, the x to the first is really easy. 1 drops down in front, 1 becomes 0, x to the 0 power is just 1, so it's really just 1. So this becomes 1. Now, the derivative with respect to x, technically it's 1 dx dx, technically. I know we haven't been writing it, but as I explained to you, dx divided by dx is just going to be 1 anyway. So that's 1 is the derivative of x with respect to x. Now, if I do the same thing with y, the derivative of y, just like any variable, is always also going to be 1, but that's the derivative of y with respect to x. So it's not the same thing. So we have to have this units. This is really 1 times dy dx. It's times, remember, dy dx is the rate of change. It's the rate of change of y. It's the derivative of y with respect to x. 1 dy dx and 1 are not the same thing at all. All right, over here, same steps. So differentiate y third, you get 3y squared. And of course, for the same reason, that's times dy dx. That's because this is the derivative of y with respect to x. It's not the derivative of x with respect to x. So it's not just times 1. All right, x times y squared. So this time I'm going to have to use product rule. First term times this is the derivative of y squared. The derivative of y squared is 2y dy dx plus the second term times the derivative of the first, 1 dx dx, which is not really needed, as I just mentioned. All right, so this is pretty much the rules for differentiate both sides with respect to x. So we're going to do this for both sides of an equation, and then collect all the terms involving dy dx and put them on the same side. And what we're trying to do is solve for dy dx. We're trying to find what dy dx is. All right, so differentiating equations in terms of x, which is most commonly what you're going to do with an implicit differentiation. All right, so we differentiate this side and this side. Derivative of any constant is 0. That's the easy side. Derivative of this is 3x squared. Derivative of this is 3y squared, dy dx. And remember, we're trying to find dy dx. We're trying to find the actual derivative itself. Now, with the x, it doesn't really matter because it's dx dx. They just cancel each other out. So the next thing I'm going to do is move this to the other side, as you can see. That gave me this. I want to get dy dx. I want to get this by itself. So I'm going to divide both sides by 3y squared. I'm really just doing my Algebra 1 skills here to solve an equation. And then once I get dy dx, the 3's cancel out, and boom, there is the derivative of y with respect to x. The derivative of y with respect to x is negative x squared over y squared. That's how the derivative would change over time. All right, same thing here. We have a y here and a y here. So we're going to have to, it looks like we're going to have to do it twice. Now, this one's tricky. Sine of y. I know you think it's just going to be cosine y, but it's cosine y times the chain of the inside. The derivative of y is not 1. The derivative of y is dy dx. So when you do the derivative of this, It's cosine of y times dy dx. Over here, 2y becomes 2 dy dx. And this is obviously just 2x. Now the key here is we have two terms with dy dx. We have one over here and one over here. We want to get them together. So I subtracted this one from both sides, factored out the dy dx, and then I can solve for dy dx. I can now find how the derivative of y with respect to x is changing over time. All right, another example. Looks like we only have one. Nope, we have two y's here again. So we're going to have to get them together. So find the derivative of each piece. There's 1, 2, 3, 4 different terms. So all I did in purple is find the derivative of each piece. Then I got rid of this to get the two dy dx's on the same side. Factor out the dy dx. And then got rid of this. And then I could simplify that down to x over 3y squared minus 2 is dy dx. That is the derivative. All right, so we're going to end with one pretty complicated question. Now we have find the tangent and the normal line. All right, so that's a pretty in-depth question. So we're trying to find the tangent line and the normal line. Remember, a normal line is really just the tangent line, only it's perpendicular going through the exact same point of this ellipse, and this happens to be the real equation. So we have a y here and a y here. Now that makes this question pretty difficult because this has got product rule. This is x times y. That's product rule, and then this is just 2y dy dx. So this is the product rule, so you can see where I got this line from. Then you had to distribute this negative sign. That's what I did next. Then I want to get the two dy dx's on the same side, so I got rid of anything that didn't have dy dx and moved it to the right. Factored out the dy dx, and then I was able to find dy dx is this. Now you don't need to simplify this. You can just leave this as is and use that into your equation. But it did say find the tangent normal line did give us a point, negative 1, 2. So you're going to plug negative 1, 2 into that derivative to find the rate of change at that point, because that's what dy dx is. It's the slope at that given point. So if we know where the point is, we should be able to plug that in here and find that the slope happens to be 4/5. And then using that point, there is our slope, point slope form, right? Y minus the given y equals the slope times x times the given x. Now I don't have normal line here, but that's a pretty easy addition. It would be negative 5/4 x plus 1, because it's literally the same equation as the tangent line. The only difference is that it's perpendicular to it. So it's the negative reciprocal of the same slope. All right, that's going to be it. Thanks again for watching. I'll see you on the next one.